Welcome back. Time to cover our first real vulnerability. Even though HTML injection is considered a bug, command injection is much more serious. So, what is command injection? Well, we can define it like this. Command injection is a web vulnerability that allows an attacker to execute operating system commands on the server that is running the application. Typically, once it's discovered, it allows the attacker to fully compromise the application and all of its data. Sometimes, command injection can be used to compromise other parts of the host's infrastructure, and it can be used to pivot the attack to other systems within the organization. So yes, it can be really serious vulnerability. It allows us to execute system commands on the server, which could also mean that we can see the files, check out the passwords folder, delete files, and perhaps even set a reverse shell connection. But how exactly do we do that? And when can we find this bug? Let's check out an example in theory. Say we have a simple web application that lets people read different stories. It gives you a list of stories that it has available, and you type in which one you want to read. Let's say that those stories are stored in TXT files on the server. Once a client types in the name of the story that they want to read, the server processes the content of that story's TXT file and outputs it back to the web page. Now, this is a very simple example, but it will give us a good understanding on what exactly is command injection. And what we saw right here was a normal usage of this web application. But the problem can occur if the website processes the content of the story itself through its system without the user input being filtered as to what characters and what commands can it receive. Let me explain this a little bit better. For example, let's say this application reads the content of the TXT file with the help of the cat command. We type in the story name and it cats the story, reads the output and throws it back to the web application for us to read. All of this is good, but what happens if we enter this, for example? Story1.txt, semicolon, who am I? And here is where our terminal commands knowledge comes in play. What we did right here is we simply typed the story that we want to read, then we used semicolon to add another command that the server should execute, which in our example is who am I? And by the way, semicolon can be used to separate multiple commands. It's just one of the ways that you can separate multiple commands and execute them one by one. So now the command that the server would process would no longer be just cat story1.txt, but it would look something like this. Cat story1.txt, and then after it executes that, it would execute who am I. And if the website is vulnerable to command injection and it doesn't filter our input, we would get an output like this. It would output a story, and at the end we should also see the response of the who am I command, which can be root or the account name that executed the command. So in general, the process looks something like this. We find a user input that could potentially get processed by the system. We add normal input and concat additional command to it, and if the input isn't filtered, it will process both of those commands and it will give us both of these results. Awesome. Now let's see how that looks like in practice. Welcome back. Let's cover our first example of command injection. And as usual, we're going to start off with an easy example first. This example will be the one from our Try Hack Me OWASP Top 10 lab. So we already ran that virtual machine once we covered the HTML injection, and we want to do the same thing again. We want to run the virtual machine used to perform command injection in the lab that we covered inside of the Try Hack Me platform. Now, since we already ran it once, I'm going to go through the process of running those virtual machines and setting up VPN one more time, just so we can refresh our memory. So the first thing that we want to do once we open our TryHackMe account is we want to make sure that Burp Suite is started and that intercept is turned off. And then we want to run our VPN file. Remember, we downloaded it in the home and then our account and in the downloads directory. And all we have to do to run it is type sudo openvpn and then the file name. Enter your password and it will start the VPN for you. Now, if you open another terminal and type in ifconfig command, you should be able to see another interface right here that will give you the IPv4 address that will belong to the TryHackMe network. Okay, awesome. Once you got that set up, you want to navigate to your dashboard, navigate to the Learn tab, scroll all the way down till we find our modules, which are right here. Select Web Hacking Fundamentals. And under here, we want to go with OWASP Top 10. Okay, awesome. As we can see, we are connected to their network. Here is our IP address. As it says even here that we are connected via OpenVPN. So everything is set up good. Now, if you don't connect from the first try, just try to restart both of your OpenVPN and your TryHackMe platform. Just refresh it after you start your VPN again, and it should work perfectly. Now, once we navigate right here, we want to go to the task 4 and task 5. Both of these are command injection. Just this one is only theory. It allows you to read something about it. You can go through all of this if you want to. I do advise you to read it. And you can also read examples of command injection right here under the task 5. But we're not going to be reading this at the moment. What we want to do is we want to start the machine. As we remember, it will take around 1 minute for our IP address of our vulnerable virtual machine to appear right here. So let's wait for that. And by the way, after we finish showing the command injection, in the next video we're also going to try to do these tasks or do these challenges right here. These are something like capture the flag challenges. So it will ask us to find something and we will try to do it with the help of command injection. But for now, let's just get command injection to work. So let's wait once again for IP address to show. And here is my IP address. I'm going to copy it. And the first thing that I always do, which I already mentioned, is I try to ping the IP address. In case you get a response like this where it is not able to ping it, make sure that you wait for a minute or two and then you should be able to ping it, since it does take some time for the machine to set up. So let's Control-C this, wait a couple more seconds and then we will try again. Let's give it a try again, and if I ping it, now we do get the response. Okay, awesome. Let's go back here, and in our challenge, as we already saw previously, we do get this link right here. So this link is what we're going to use to try to perform command injection. Let's click on it, and it should open a page called evilshell.php on our target's IP address. And here we get a simple web application. It only has this one input that allows us to enter a single command. And if I type something like test, well, nothing will appear. But what would happen if I type something like test and then semicolon to separate the commands and type ls, which is the command to list all the available files in the directory. If I click on submit, now we get a response. We get all the files that are currently in this web server's directory. So this input right here is vulnerable to the command injection. You can do this with any command that you want. You can type test and then semicolon and then, for example, who am I? And it will tell you which account is it running as. Currently it's running as www-data. So command injection works in this input. But there's one more thing that I didn't really tell you. Besides the command injection that reflects the output on the page, there is also something called blind injection or blind command injection. What does that mean? Well, it means that we can't see the output of our command on the page, even though it might be vulnerable to the command injection. Okay, but you might be wondering, well, how can I then know if it's vulnerable if I can't see any output on the page? Well, we have to approach it differently. Now, let's imagine that this same page doesn't give us any output. Let's imagine that once we type test and then semicolon and then space and ls, it doesn't print anything right here. If you didn't know about blind command injection, you would probably think that it's not vulnerable. But there is another test that we can perform. We can try to perhaps ping our Kali Linux machine from our target machine. It won't give us any output here, but if we try to intercept the requests using something like a Wireshark, then maybe we can see the packets that the target machine is sending in order to ping us. If we do see those packets, that means we have a blind SQL injection. Let me show you what I mean. So first thing, we're going to open a program called Wireshark that is used to sniff packets and data over certain interfaces. We do ideally want to open it with sudo, just so we don't have any limitations. So just type sudo Wireshark and then type in your password. It will open this user interface program where we are going to try to sniff our packets once we run the ping command. So you will open a window that looks something like this. And you will have multiple interfaces right here. Ideally, we want to select the interface that we use with our VPN. And once again, you can figure out which interface that is by typing ifconfig. And for me, this is TUN0 interface. It has the IP address that belongs to the TryHackMe network. So I'm going to select that one right here. And here it's going to sniff for all the packets that are coming to that interface. Now, in order to discover this blind command injection, what we can do is we can type test and then ping our IP address. So to check out what IP address we have, we can copy it from our ifconfig output right here, and we can paste it here. But before we run it, we want to be specifically sniffing for ping requests inside of our Wireshark. And those packets are also called ICMP packets. So you can type in the search bar ICMP, press enter, and it will only output any ICMP packets that are received right here. So let's give it a try. We typed test, semicolon, then we added space for the second command, and we typed ping and then the IP address. Now, also since Linux systems ping forever until you Control C, we also want to add -C option, which stands for count, and we want to ping only 5 times. So we were going to type ping, IP address, then space, -C, and then 5. In case you don't see it really well, let me enlarge this, and it looks something like this. Once we submit this request, you will notice that this page is loading consistently. And after a few seconds, we get this output. But if we go to our Wireshark, we also get ICMP packets from the target machine. Now, imagine that we didn't get this output right here. We would think that there was no vulnerability. But if we opened our Wireshark and saw the requests coming in, we would know that we have a case of blind command injection. How cool is that? Okay, awesome. And this was the simple example of command injection. In the next video, we're going to take a look at these tasks right here, even though they don't really have much to do with the command injection, but more like system navigation and something like that. But we're nonetheless going to do them just to show how you can approach these challenges. Thank you for watching, and I will see you in the next lecture. Welcome back. Let's try to solve these challenges inside of our command injection task. Now, this is something that we do as a bonus. It has very little to do with the vulnerability itself. It's more like what you're going to do after you find the vulnerability. And we're not going to be doing all of these challenges on TryHackMe platform. However, we might do a few of them just to see whether we can solve them. So navigate to your command injection, which is task number 5. Make sure it's command injection practical. The requirements for this is that if you want, you can read through this and this part right here. And also you should have watched the previous video where we performed the command injection. Right now, let's use that command injection to solve these examples. Let's go with question number 1. It asks what strange text file is in the website root directory. Well, we already know how we can do this. To list all of the files in that directory, all we can do is type ls. So we can type something like test to finish off the first command, even though it's not necessary for this virtual machine. However, we just do it for practice, and then semicolon, and then we can type ls. This will list all the files in the current directory. And let's get to the question again. We're searching for a strange text file. Let's go back, and pretty much the only text file that we have right here is drpepper.txt. So let's copy that name and specify it right here as a first answer. Okay, it's correct answer. Awesome. Let's go to the second question. Now, it asks how many non-root and non-service, non-daemon users are there. Well, this might be a little bit tricky because for this, we can do something like this. So test, semicolon, and then we can cat @c and then passwd folder in order to see all of the users that the system has. Now, we are searching for non-root and non-service users. And if we take a look at this output that we get right here from the @c passwd folder, well, pretty much we don't have any personal user outside of all of the other users tied to a service, such as proxy, such as no login, such as network, and all of that. So the answers to this should be 0. Let's submit it. And that's also a correct answer. Awesome. The third question is the one that we already performed in the previous video, which is what user is this app running as? So we already did this in the previous video. We can type test, semicolon, and then who am I, and it will tell us the user that's currently running this web application. In our case, it's www-data. Let's copy that and submit it for the third answer. The fourth question is what is the user's shell set as? Now, this is something that you can also try searching inside of the @c passwd folder. Let me show you what I mean. Once you cat the @c passwd folder, it will give you this output, and all you want to do right here is try to find the www-data user. And if we go and scroll a little bit, it's right here. At the end of that user's line, we should be able to find a path that says /user/has-been/no-login. Let's give it a try. Let's copy that. This is the path that we get, and if I set it right here, let's see whether it's correct, and it indeed is correct. So all we had to do is cat the @c passwd folder, find the www-data user, and at the end of the line you will have the path that is the answer to the question of what is the user's shell set as. Okay, awesome. Now, the fifth question is what version of Ubuntu is running? And most of these questions are something that we can actually Google if we don't really know. So for example, let's say that we don't know what command can we use to discover the Ubuntu version. We can try something like this. How to check Ubuntu version. Press enter, and we can visit first or second link, it doesn't really matter. Let's go with this one, how to check your Ubuntu version. And ideally we want a command that is used to do that. So let's scroll a little bit down. And it says use the lsb release-a command to display the Ubuntu version. So let's give it a try. If we copy this command and we run it inside of our evil shell, so test, semicolon, and then let's paste the command. Okay, so we do get the output. Here is the Ubuntu version. And which format are we looking at? We're looking at a number.number.number. So it's pretty much this, 18.04.4. 4. Copy that, this is the Ubuntu version, and paste it right here. Awesome. Now, the last question is the trickiest, because it says print out the MOTD. What favorite beverage is shown? Now, pretty much 99% of you are going to take a look at this question and wonder what even is it asking, but I advise you to straight away go to hint. So the hint tells us 00-header. And this sounds like a file, perhaps, or something like that. So we can start off with that. We can try to locate a file that has this inside of the name. How can we do that? Well, we can use a locate command that most Linux systems support. So we can type test and then semicolon. And by the way, just so you don't get confused, you don't need to type test every time. You can type anything, so pretty much anything at all. You can type test 1, 2, 3. The word that you type before the semicolon is really not important in this case. So you can type pretty much anything and then semicolon, and then comes the important command. So we want to locate, and what are we locating? Once again, we're locating 00-header. Let's copy that name, and let's paste it in our command. Click on submit, and we get this output, which sounds like a path, which is under the /etc/update motd.d/00-header. So let's try to cat this, but let's make even more complex command. Let's type test semicolon, and then let's cd /etc/update-motd.d, and let's concat another command, which we can do by typing 2 of these signs right here. And then we can type cat 00-header. So here we're actually trying to execute 3 commands. The first command, which doesn't really matter what it is. In this example of this virtual machine, you don't even need to use it because it's specifically made to execute commands. But in real life, you will have a first command that should be normal web application usage. Then after that comes our command injection, where we execute our first command, and in this case we concated another command. After we cd to this directory, we want to cat the content of this 00-header. Let's submit this, and this is the output that we get. So now let's go back to the question, what favorite beverage is shown? Let's go all the way down, and if we scroll, we're going to see something interesting right here that says Dr. Pepper makes the world taste better. We can copy this, go back to here and paste it right here. Oops, let's try like this. No, that doesn't appear to be the answer, so... we should just copy Dr. Pepper if I'm not mistaken, not the entire sentence, so let's go back and let's paste Dr. Pepper. And here it is. That's the correct answer. So this was just a little bit of a bonus video where we covered these tasks right here using different commands. And in the next video, we're going to take a look at how we can run a reverse shell with the help of a command injection on our OWASP BWA virtual machine. See you in the next lecture. Okay, let's try and solve some command injection challenges on our OWASP virtual machine. So what you want to do is make sure everything is started. Burp Suite is started, even though we're not going to use it, but we need it just in case. Maybe we are going to need it, maybe we're not going to need it, we don't really know that. Also, besides Burp Suite, open your OWASP virtual machine, and once you have all that ready, we want to navigate to the OWASP Motilday 2. Now, here on OWASP 2013, we're going to see under the injection, command injection, right here. And we can go with any one of them, so let's go with DNS lookup. It will open this simple page. So it says, who would you like to do a DNS lookup on? Enter IP or hostname. Let's say, for example, we type in google.com. And just so we can see everything better, I'm going to zoom this in. Let's say we type www.google.com and click on lookup DNS. And this is the output that we get. And straight away, just from the output, we should be able to notice that this output looks quite similar for us. It almost looks the same as the output from the NSLOOKUP command. And as we already know from our Linux knowledge, NSLOOKUP command is used inside of the terminal. So if I typed www.google.com to the NSLOOKUP, we would pretty much get almost the same response. So maybe this application is using its system to execute this command and give us the result back. And whenever this happens, we already know there might be a possible command injection. So let's type www.google.com, semicolon, space, and then let's type who am I. Click on lookup DNS, and this is the output that we get. We have a command injection. As we can see down here, it executed our who am I command. We can do the same thing with ls or any other command that we can run in terminal, and it should also run. As we can see right here, our ls command gave the output of all the files in this current working directory. So this was rather easy. We found the command injection. But let's take it a step further. Let's try to establish a reverse shell with the target system with the help of a command injection. And if we take a look at these outputs or these files that we got with our ls command, it seems that the server is running PHP, which is most common, to be honest. So most likely servers will be running PHP. And maybe we can do something like a PHP reverse shell. Now, even though we're not PHP coders, these type of one-line reverse shells are very easy to find online, and you just need to Google PHP one-line reverse shell or bash one-line reverse shell, and it will give you a single command that can be used to establish a reverse shell connection with our Kali Linux machine. So I got one of those commands right here. It's written right here in my Nano editor, and all this command is doing is it's running PHP code where it creates a socket object, and socket object in programming language is something used to establish a network connection. In the brackets between the double quotes, we have our Kali Linux IP address, so this is my Kali Linux IP address, and here is the port that we want it to connect to. The second part of the command is what we want it to execute once it connects, and this entire part simply tells execute the bash shell and make it run as much commands as we want. So this is the entire thing that this command does. It connects to our Kali Linux IP on the specified port, and it executes the bash shell for us so we can execute the commands. But in order for the target machine, which in our case is OWASP BWA, to be able to connect to our Kali Linux machine, we must listen on an open port for the incoming connections. And we can do that easily by opening terminal and typing nc, which is netcat, -lvp, and then the port that we want to listen on. This -lvp simply stands for listen on any interface that Kali Linux has. So we're not specifying the exact interface, we're pretty much telling accept the connection on whichever interface that you get the connection from. So it's nc-lvp and then space, and here we need a port. And if we go back to our command, let me find it. In this command we specified the port 1234, so we must use the same port inside of our netcat command. So we would type nc-lvp and then 1234. And this is pretty much all we have to do. It says listening on any interface on port 1234. Now we want to copy this command and make sure that you get all of these single quotes and double quotes right, because otherwise it will not work. And then we want to execute it right here. So let's go down and type www.google.com, semicolon, and now let's paste the entire command here. Click on lookup DNS, and the first thing that you will notice is that it's loading the page. It's not outputting anything for us. It's just continuously loading. And if we go back to our netcat window, here it is. We got our reverse shell opened, and we're on that machine currently as www-datauser. Here we can execute all the commands without having to go to the web page. We can just type who am I, we can type ifconfig, we can type ls, we can type pwd to check current working directory right here, and we can type anything that we can run from a normal terminal. We can even try to, for example, execute one of these PHP files if we want to. So this is really good because now we have a reverse shell established on the target machine, and we can do anything that we want, including deleting files, creating files, navigating through the system, downloading files, uploading files, and all of that. So that's really cool. Even though you can do all of that with just typing in the commands right here, it's much easier once you have a reverse shell established where you can just type in the command in the command line. Now that we did that, we covered a little bit of an advanced example of exploiting command injection, and in the next video we're going to take a look at one last example of command injection, which will be on our DVWA on our OWASP virtual machine. See you in the next video. Welcome back. Let's see an example of command injection on our DVWA page. So open up your OWASP and navigate to the DVWA. Here we are going to log in with our credentials and make sure as usual that intercept is turned off so we can navigate between the pages. Now, once we get to this page, we want to go to this part right here that says command execution. It's essentially the same thing as command injection, they just named it differently. Let's go there, and for this first example, make sure that security level is set to low, and we'll be checking out security level low and security level medium. I believe in these newer versions of DVWA, the high security level is actually not vulnerable, and it's an example of how the code should look like once the input is not vulnerable, or once the input is filtered properly. So, right here it tells us ping for free. We can enter an IP address, and it will ping that IP address. Here I typed in the IP address of my router, and it performed 3 ping requests, and it outputted the results right here. So already by seeing these results, we can imagine that the page is performing something like this. Ping 192.168.1.1 -C for the count and then 3. Then it pings the router 3 times and it outputs this result back to us on the page. So this page is interacting with the system. Now let's try to inject our command. So I'll type in the IP address, and by the way, this IP address most likely won't work for you. This is just my router's IP, so feel free to try with a different IP instead, whether it's external IP address or a local IP address inside of your network. And now let's type semicolon and let's type ls. Submit this. And here is our command injection. It executed the second command as well. So simple as that, we managed to run our command injection, and now we can do pretty much anything that we performed in the previous videos, such as running reverse shell, such as taking a look at different accounts and passwords and all of that. But this is not why we performed this example. We want to see how we can also perform command injection on security level medium. So to change the security level on DVWA page, navigate to here that says DVA security and change from low to medium. Click on submit and go back to the command execution, and down here you should see that now the security level is set to medium. So let's try the same thing. Let's go with the IP address first, just to see what type of output do we get. And we get pretty much the same output as before. Now let's try to execute our ls command by typing semicolon, space, and then ls. Nothing happens. And you will notice that on this DVWA page, we do have the source code to how this input is filtered. This source code is written in PHP, and we're going to take a look at it just so we can see why our command injection doesn't work now. So let's open the source code. As I mentioned, it's written in PHP. Even though we don't really need to know PHP, we can try to guess what this code is doing. So this is the IP address that we input, or should I say the command that we input, and now it performs this part right here, or should I say this part. This is the important part for us. So it creates an array that uses these characters. And we can see our semicolon right here. So it pretty much every time in our command that it sees semicolon, it will change it to nothing. Same goes with these two signs. And by the way, these two signs are also used to concat different commands. Let me show you in terminal. So you can type something like ping 192.168.1.1 -c3, and then you can use these two signs to also run ls right afterwards, as you can see right here. So semicolon is not the only way that we can concat commands. And we can see both of these ways are filtered. It will replace them with nothing in this line right here. And that's why our ls command doesn't work. So does this mean that the input is not vulnerable? Well, not really. There are more ways that we can concat commands. For example, we can type ping 192.168.1.1 -c3, and then instead of using two of these signs, we can just use one of them, and it will still work. Let me show you. If I type one sign and then ls, here it is. It printed out both of these things done. It just did this first command straight away and the second command right after. But it did perform both of these commands. So can we try something like that right here? As we can see, it's not filtering just one of them, it's filtering once it sees two of these signs. Well, let's give it a try. Let's try to ping 192.168.1.1 and use one of these signs and then ls. Let's submit this. Whoops, it actually won't work because we typed ping, so we just need to type an IP address and let's say who am I. Let's type who am I this time, just by using one sign to separate the commands. And we do get both of the outputs back, just the who am I output is somewhere in the middle of this command. That is because once you type only one sign and not two of them, it actually executes both the command simultaneously, and whichever output comes first will be printed out right here. And currently we got the output of who am I in the middle of the ping command. But we did run our command injection on medium security level. Awesome. And in reality, you wouldn't really have this source code right here. You wouldn't be able to see the PHP code. However, you would try all of these signs. You would try semicolon, you would try both of these signs, you would try one of the signs. You can also try the pipe character in order to concat different commands. And all of those things could be filtered, or maybe most of them are filtered, but you do manage to find one sign that isn't, that will allow you to perform command injection. So you would just try all of them and see whether any of them works. Now that we covered command injection, in the next section we're going to cover another big set of vulnerabilities that is called broken authentication. See you in the next lecture. Broken authentication. Just by its name, we can already assume what type of vulnerability this is and what it does. And this is one of the most common attacks and vulnerabilities in past years. Now, broken authentication is usually tied to sessions, but let's define a session first. So, what is it? Well, we can say sessions are a sequence of network transactions or network requests associated to the same user for a certain period of time. This is what identifies an individual on a web page, a session. Now, don't confuse sessions with authentication. Even though they are quite similar and sessions do interact and do change based on whether a user is authenticated or not, sessions are established even when a user is not authenticated. It's just that it changes once a user does authenticate on the website. Okay, but regarding broken authentication, what attacks do we have? What can we do to test for this vulnerability? Well, there are different types of the attacks. but we can separate them into two different groups. Group number 1, which are attacks that the user is responsible for, and group number 2, attacks that the developer is responsible for. Okay, so both sides take place into making these attacks work. How exactly? Well, users are responsible for their credentials. They're responsible for making their password as strong as it can be by adding numbers, characters, upper and lower case letters. However, usually this isn't the case, and they choose an easy password that has a meaning to them. We can target this with attacks like brute force of the credentials. We can brute force usernames, passwords, security questions, and anything that we need to get into an account. These type of the attacks we will cover in the next section. However, in this section, we're more interested in covering mistakes in website configuration that allows us to steal a session. These web developers are responsible for the session management, how the website is going to process different sessions, and what parameters is it going to use. Usually, these sessions are identified with cookie values or URL type parameters. Sessions are considered as important as user credentials. A hijacked session ID is as strong as a stolen login credential. And that is the attack that we will mostly be doing, session hijacking or session stealing. There are many approaches as to how we can do that. One of them is an attack called session fixation. The main idea behind this attack is that the attacker predetermines the session ID that the victim will use. For example, the attacker could send the victim a link that contains a predetermined session ID, and that link might require the victim to log in. After they log in, the attacker can then use that session ID to impersonate the victim after the victim logs in. There is also a possibility of weak encryption or weak cookie values. It can be that the website transmits the passwords in plain text or in a weak encryption that can easily be reversed. This is also a point of attack for hackers. Credentials should have best encryption possible since they are the main things keeping someone to have an unauthorized access to another person's account. Same goes with cookie values. They have to be random and unpredictable. Now, different examples of broken authentication attacks we're going to see in this section, while brute force attacks and similar we will do much more in the next section. So get ready and let's get straight into practical examples. Okay, let's cover our first basic example of broken authentication. And for this, we're going to start off with TryHackMe platform. So make sure everything is started, you have your burp suit, you have your VPN running, and make sure that you also get the IP address for the VPN. Once you do all of that, navigate to the TryHackMe platform and go, as usual, to our web hacking fundamentals and navigate to our OWASP top 10 room. Here it is. Let's go right here. And we already know right here we got a bunch of different tasks, but for this lecture we want to navigate to task number 6 and task number 7. Now, if you want to read about broken authentication a little bit, you can read through the task number 6 and then navigate to the practical part, which is task number 7. And this task is rather easy. So let's take a look and let's read what it asks from us. But before we read through this task, let's start our machine, because we already know that it takes about a minute or two in order for it to start properly. While it's starting, let's read through this task. For this example, we'll be looking at a logic flaw within the authentication mechanism. A lot of times what happens is that developers forget to sanitize the input given by the user in the code of their application, which can make them vulnerable to the attacks like SQL injection. Okay, we already knew that. Let's go all the way down. Let's understand this type with the help of an example. Say there is an existing user with the name admin. Okay. And now we want to get access to their account. So what we can do is try to re-register that username but with slight modification. We're going to enter space and then admin. Notice the space in the starting, okay? Now when you enter that in the username field and enter other required information like email ID or password and submit that data, it will actually register a new user, but that user will have the same right as normal admin. That seems to be quite a big of a problem. Let's continue reading. That new user will also be able to see all the content presented under the user admin. To see this in action, go to this link. So let's visit it straight away. And let's go down just to read until the end and try to register a user named Darren. You'll see that user already exists, so then try to register a user space Darren. And you'll see that you are now logged in and will be able to see the content present only in Darren's account, which in our case is the flag that you need to retrieve. Interesting. And the first question is, what is the flag that you found in Darren's account? So let's go and take a look. If we try to log in as Darren by typing Darren and let's say test1234 and click on sign in, we get an error, invalid username or password. So let's try to do what the try hack me example told us to do, which is to register a user with slight modification. So let's type space and then Darren. Make sure there is space right here, otherwise it will not work. And under the email, we can type any email that we want. I typed test@gmail.com, which is probably a non-existent email. And under the password, I will type test1234. And I will register this user. Okay, so we registered the user successfully. Now let's try to log in as that user and see whether we will be able to find the flag that should only be accessible from Darren's real account. So let's go right here, type space and then Darren and test1234. Let's click on sign in and here is the flag. So we successfully performed a broken authentication attack where we registered a new user with slight modifications such as adding space at the beginning of the name, and it allowed us to see the flag that should only be accessible from the real Darren user. And we would submit this flag right here under this question. Okay, and the other question is try to do the same trick and see if you can log in as Arthur. So I assume the Arthur account already exists, so pretty much we can do the same thing. We can go register, add space, and then Arthur. And for the email, we can type once again anything that we want. I typed test2@gmail.com and password will be test12345, just to make it different than the Darren's account. Now let's go and log in. So add space, Arthur, and test12345. Click on sign in, and here we get the Arthur's flag as well. So we pretty much performed the same thing for two different accounts, for Darren's account and for Arthur's account. And if this type of vulnerability was to exist in a real page, we would pretty much be able to access any account on that page just by knowing its username. We would then perform a slight modification, register a new username, and we will be able to see all the things that original user can see. Okay, but this was a rather simple example of broken authentication. In the next video, we're going to go back to our OWASP BWA and try to take a look at a different broken authentication attack. See you in the next lecture. Welcome back. Let's see a different example of broken authentication attack. And to present this, we're going to be using OWASP Motilday 2. So open up your OWASP machine, navigate to the Motilday 2, and under here we want to go to OWASP 2013 and navigate to Broken Authentication and Session Management. Right here we want to go to the Authentication Bypass and let's go to Bypass via Cookies. Click on that, and this is the page that we want to, let's say, hack. But let's read through this first. So some sites keep authentication and or authorization tokens in the user agent field. This gives the user large amounts of control over these tokens. Okay, but do we really need to read through all of this? It just tells us that some different attacks are possible, such as SQL injection, brute force, and secret administrative pages. But let's read the name of our task again. So it's broken authentication. We want to bypass authentication, and we want to do it via cookies. Okay, to be able to do this, we need to have an account on this page. So let's create a simple account by going on login and register. And we don't have an account, so let's register right here. We're going to type username. Let's type username test1 and password, let's say test1234. We will confirm the password and the signature is not needed, so let's just create an account. Okay, it tells us account created. Now let's go back and let's go on login and let's log in with our account. So the username was test1 and the password was test1234. Okay, awesome. Let's close this window and in the right corner we should see logged in as user test1. Now let's go back to our page and try to bypass and switch the account by changing the value in the cookies field. So let's navigate to our burp suite, turn on the intercept, and let's try to refresh this page. Let's take a look at the request that we're trying to send. And if we go down, here is our cookie value. Now we can see there are multiple fields to this cookie value, but there are two particular fields that should be of interest to us. We got username equals test1, we got user ID, we got PHP session ID, but these two right here do seem interesting to us the most. Let's try to change the username from test1 to, let's say, admin, because there is an admin account on the Moodle page. And if we forward this request, nothing really happens. We're still logged in as user test1. So maybe we can't do it like that. Let's try with the user ID field first. So let's turn off the intercept, turn it on back again, and let's refresh the page. Now we get the same request. We got the username test1, which is us, and we got the user ID. Apparently 25 is the user ID of our test1 account. Let's try changing that to 1, for example. Let's forward this, go back to the page, and here it is. We managed to switch the account by changing the values inside of the cookie header. Now it says logged in as admin. Here is our account. And we can do that for any account that we want. If I refresh the page and change the user ID from 25 to 2, forward, now we should get a different account, logged in as Adrian. How cool is that? And this is a vulnerability in the session management. It allows us to switch the accounts by changing the user ID in the cookie field. So this was also a simple example, and in the next few lectures we're also going to take a look at different approaches to broken authentication attack. Let's cover yet another attack for broken authentication, and this one will be aimed at authorization within the page. To demonstrate this, we're going to go to a page called OWASP WebGoat. It's right here. Let's click on it, make sure that intercept is turned off, and it will open a window like this that will require us to log in. And remember this window because it will be important for us in this lecture. So we got this pop-up window, and to log in we can type guest and then as password also guest. So username guest and password guest. Click on OK. Let's not save the password and it will open a page like this. From here we want to start our WebGoat. And let me just zoom this in a little bit, and here we will have different attacks that we can perform. Of course, not all of these attacks have to do with broken authentication. Most of them actually are different vulnerabilities, but the attack that we are interested at the moment is authentication flaws. So click on that, and from here we want to go to basic authentication. Okay, it will open a task like this. So it says basic authentication is used to protect server-side resources. The web server will send a 401 authentication request with the response for the requested resource. The client-side browser will then prompt the user for a username and password using a browser-supplied dialog box. And that is the dialog box that we saw once we logged into Webgoat. The browser will base64 encode the username and password and send those credentials back to the web server. The web server will then validate the credentials and return the requested resource if the credentials are correct. These credentials automatically resend for each page protected with this mechanism without requiring the user to enter their credentials again. So essentially what this says is that our basic authentication credentials that we inputted once we logged into our Webgoat will be processed through every page within the HTTP request without us having to log in every time we switch a page. But the problem here is that it's encoded with base64. So here we will have a vulnerability of weak encryption and weak encoding. Base64 is something that we can easily decode. So let's give it a try. For this lesson, your goal is to understand basic authentication and answer the questions below. What is the name of the authentication header and what is the decoded value for the authentication header? Okay, let's go right here, turn on the intercept, and this is also a rather simple example. If we go to our HTTP header, we get this field that's called authorization and it says basic and then some random letters. Now, we got our answer to our first question. Authorization is the answer to what is the name of authentication header. So we can type it in, authorization, even though it doesn't matter since we are in the middle of refreshing the page, but nonetheless, let's take a look at this more interesting part that says basic and then some random letters. Now, we already know that this is base64, and you can usually recognize base64 by this equal sign at the end. Right here it also tells that it's basic authentication, so what we can do if we were to, for example, intercept this request by using something like a man-in-the-middle attack on a wireless network, and we were to get this request from some other user that's trying to visit a page within the Webgoat, we will be able to decode their username and their password and then log in to their page. Let me show you how we can do that. We copy the value that's encoded right here, and then we go to something called decoder. Here you can turn off the intercept and navigate to the decoder. Now, decoder is something that we didn't cover in the Burp Suite Basics, but it's rather simple to use. All we have to do is paste right here what we want to decode. And let me see if I even copied it. Okay, I copied it successfully. And right here on the right side, we want to click on decode as, and we want to decode it as base64. Let's click on that. Wow, here it is. Here's our username and password in plain text. And that is all it took for us to get the username and the password of a certain user. Now, of course, for us to be able to get this HTTP request that we intercepted, as I mentioned, we would have to do something like a man-in-the-middle attack, but that's really easy to perform. The problem right here is that the page has a weak encoding, and then we can easily reverse the encoded username and password back to the plain text. And now we can copy this because this is the decoded value, since that is the answer to our second question on the page. And let's paste it right here and submit. And it will tell us, congratulations, you have figured out the mechanism of basic authentication. Now you must try to make Webgoat re-authenticate you as username basic, password basic. Use the basic authentication menu start at the login page. Now, all we have to do right here is simply just to close the Webgoat, and then we would re-authenticate with basic and basic as username and password. So this is something really easy to do. We're not going to cover that. Just next time at the login screen, you can use this username and this password to enter a different account. And you can also try to intercept a request on a certain page and try to change the encoded value of basic and basic in the authorization header in order to switch the account. That might work too, you never know. Okay, awesome. This was yet another simple example, and in the next video, we're going to take a look at the example of broken authentication once a user forgets a password. Nonetheless, thank you for watching, and I will see you in the next lecture. Okay, let's take a look at another example of broken authentication with the forgot password. Now, an example of this, we're going to take a look at our webgoat. We introduced ourselves to the webgoat in the previous video, and now we're about to do another challenge using this application. So let's click on OWASP webgoat. Let's log in with guest and guest. Now we can log in with any account that we want. We know that there is an OWASP account, and we also know that there is a basic account. But it doesn't matter for this task. All we have to do is start our webgoat right here and navigate to the authentication flaws and then forgot password. Okay. Now, let's read through the task. Web applications frequently provide their users the ability to retrieve a forgotten password. Unfortunately, many web applications fail to implement the mechanism properly. The information required to verify the identity of the user is often overly simplistic. Okay, let's take a look at the general goals. Users can retrieve their password if they answer the secret question properly. There is no lockout mechanism on this forgot password page. Okay, and that is the first vulnerability. Every time a page should block an account or block an IP address once they type the secret question incorrectly for 3 or 5 times, and also once they type the password incorrectly for multiple times. Then the page should lock you out or block you for a certain period of time. And that is a good practice against brute force attacks that we're going to take a look at in the next section. But for now on, let's solve this challenge. So webgoat password recovery. Please input your username, cd OWASP admin if you do not have an account. Required fields, username. Now, we already know of a couple of usernames, but for this video we're going to try to brute force a username. We will use a list of most common usernames in order to see whether this application has a username like that. So how are we going to do that? Well, it's rather simple. Let's type anything right here. So for example, let's type test and we're going to intercept our request. Let's submit this HTTP request, and this is the one that we want to use. As we can see, we have a field called username, and that field we want to send to intruder. Let's turn off the intercept. Of course, we are going to get not a valid username because test account does not exist on this page. But inside of our intruder, we can set our payloads accordingly in order to try to guess a username. Okay, let's clear out all of the fields. And this can be considered a semi-brute force attack because we are going to try to brute force a username as well as the secret question. Okay, first of all, we want to select the username field. I select it by clicking on add, and now we want to go to payloads. Here we want to load a list of most common usernames, and luckily our Kali Linux actually has some word lists that can help us do this. All we have to do is click on load and navigate to the word lists directory. So make sure that you go first to the / directory, then to the user, right here. Then let's go to share. Then let's try to find word lists directory, which is right here. In the word lists, I'm going to go to Metasploit, and from here I can choose the best list that fits this challenge. And for this, I'm going to go with http default users.txt. I'm going to double click on that, and it will load these usernames right here as my payload list. Okay, awesome. All we have to do right now is start the attack. And how are we going to know which username is correct and which isn't? Well, usually it's rather simple, and I will show you in just a second how we can recognize it. Okay, our username brute force has finished, and here are all of the results. As you can see, for each of these usernames we got status 200. And there's not really anything right here that says which username is correct, and if we even found a single correct username out of these ones. But if we take a closer look at the length of our response, which is right here, this number is the length of our response, you will notice that all usernames have the same length except this one, except the admin username. Usually this is an indication that there is something different with this type of username because it gave a different response than the rest of these ones. So the next thing that we can do, we find the username with a different length, we right click on it, we request or show response in browser. Then we copy the link and navigate to that link inside of our browser. And here's the secret question. Since we got the secret question, that means that we found our existing username. And the secret question is, what is your favorite color? As you can see, this is a really bad question for security because there are like 10 colors in existence and we can easily brute force that the same way that we brute force the username. So let's do that right here. We're going to go to our burp suite, let's go to our proxy and turn on the intercept. Right now we're going to type test once again because we don't really care what we write right here. All we want is to send this HTTP request to the intruder. Turn off the intercept and let's navigate to our positions. Let's clear all of these fields and let's only double click the color field and click on add. Now we go to payloads and here we can manually type the colors. For example, let's go for green, blue, yellow, and let's type every single color that we can think of. Let's go with green, let's go with black, white, and let me see, brown, perhaps, and maybe I forgot something, but let's give it a try with these colors first. So we loaded 9 payloads or 9 colors, and if we start the attack, we're pretty much looking for the same thing. We're looking for a color with a different response. But here we actually got more than 2 lengths. We got colors with this length, we got colors with this length right here, and we got a single color with this length, which is 31973. And usually this is the one that you want to check first because it has a unique length, which usually means that it's the correct one. So let's right click on green and let's show response in browser, copy this and navigate to our Firefox and paste the link. And here it is. We successfully guessed the username as well as the secret question for this account. So what exactly was a vulnerability here? Well, there are 2 things wrong with this. The first thing is that it doesn't block us after certain incorrect requests. And the second thing is that the secret question is rather easy and we guessed it in 2 seconds. Now we have finished this challenge and we have username admin, color green, and here is the password for the admin account. Okay, awesome. We have one more challenge or one more example left to do from our OWASP WebGoat application, and after that we're going to move to the brute forcing section. See you in the next lecture. Okay, the last task for us for this section is something called session fixation. And we got a pretty good example of it inside of our WebGoat application. To navigate to it, make sure that you go to Session Management Flaws, and under here you want to click on Session Fixation. And here is our challenge. So let's see what it says. We got stage 1, you're Hacker Joe, and you want to steal the session from Jane. Send a prepared email to the victim which looks like an official email from the bank. A template message is prepared below. You will need to add a session ID, or shortened SID, in the link inside the email. Alter the link to include a session ID. Okay, and we already mentioned or talked briefly about session fixation. It's simple as predetermining a session ID for someone, then that someone clicks on our link with a predetermined session ID, they log into their account and we can access their account because we do know their session ID. And this is an example of how we can do that. Let's see what we need to do. So here is an email, and in this email we have this sentence right here. Please use the following link to verify your account data. And here we have the link, which is in the href statement. So href equals webgoats/attack, and here are some parameters. Now, the first thing that I noticed is that this webgoat is written incorrectly. We need to type capital W and capital G, the same way that we have it right here. The second thing that is more important is us adding a session ID. And a session ID is simply a link parameter. So we already see some link parameters, and they're divided by this character right here. So all we need to do is to copy that same character and add another parameter at the end. Let's Ctrl V to add this character, and then add our SID parameter by typing SID equals, and here we can pretty much type any session ID that we want. For example, let's go with 555. This is the session ID that I've chosen. So now our altered link looks something like this. We have /webgoat/attack, and then these three parameters, which our last one will be the session ID. Now we as a hacker are sending this email to the victim. Let's send the email. And we completed stage 1. Now stage 2 is, now you are the victim Jane who received the email below. Okay, so now we're acting like Jane. If you point on the link with your mouse, you will see that there is an SID included. Click on it to see what happens. Okay, so let's pretend that this is the email that we got, and here's the link that we altered. Let's say that the victim clicks on this link, and it leads it to a page where they can log in. Now here, luckily, we got our username and password for the victim, which the username is Jane and password is Tarzan. So let's type that in right here. These are the correct credentials that, of course, the hacker wouldn't know, but we're acting as both the hacker and the victim in this challenge. And let's log in. And we've completed stage 3. It is time to steal the session now. Use following link to reach Goat Hills Financial. Okay, so in this challenge we're Hacker Joe. And if we go to the link, now we need to log into the session. But we as a hacker don't really know the correct credentials, so we can type anything right here and see what type of link do we get. Just by looking at this link right here, we already see that there is a session ID parameter within the link that says no valid session. Let's give it a try. I'm going to go right here and turn on my intercept. And I'm going to type in test as username and test as password, which is of course incorrect, but all we want to do is to intercept this request. Right now, we want to change this session ID to the number that we sent to the victim, which in our case, or in my case, is 555. We don't need to alter anything else. We can leave the incorrect details, and if we forward this packet, go back, we have successfully logged in as Jane, just by changing the session ID that we sent to the victim over that email. And that is the end of the challenge. As it says, congratulations, you have completed this lesson. Okay, awesome. We have covered some of the basic attacks over broken authentication, and in the next section we will continue just with different types of the attacks that we call brute force attacks. Nonetheless, thank you for watching, and I will see you in the next lecture. Welcome back. Time to perform our brute force attacks. We're going to cover a couple of examples of brute force, whether with burpsuit or some other tool, but nonetheless the principle behind them is always the same. We want to use lists with bunch of usernames and passwords to try to guess credentials of a certain account. So this doesn't always work. Matter of fact, it usually won't work unless the target has a common username or a weak password. The first example that we will cover is going to be with our burpsuit intruder. We already saw a couple of examples of using intruder, but right now we're going to take a look at a different approach to this attack. So first that we want to do is we want to navigate to this application that says OWASP Bricks. Click on that and it will lead us to this page. Under the Bricks tab, we will have a sub-tab that says Login Pages. Click on that and here we will have multiple login pages that we can practice on. Now for this example we're going to go with login number 1, and then if you want you can practice on the rest of the logins. the steps to performing this attack will be the same for each challenge right here. Okay, let's navigate to login 1, and we have a simple login form. If we type test and test, it will tell us wrong username or password. Okay, let's intercept this request right here inside of our burp suite, and let's send it straight to the intruder. Here we can turn off the intercept right afterwards, and let's navigate to our positions tab inside of our HTTP request. So down here we have our username and password field. Now before, when we used intruder, we used this attack type sniper and we only targeted one field. Right now we're going to target two fields at a time, the username field and the password field. So let's first clear all the other payloads, and let's double click on username, click on add, and double click on password and also click on add. Under the attack type, we want to switch from sniper to cluster bomb. And if you remember correctly, the cluster bomb is the attack type where we can use multiple payload sets in order to perform the attack. In other words, we have multiple input fields that we want to brute force, the username and the password field. Now let's go to the payloads tab, and it looks rather the same. Just this time we have payload set 1, and we can also choose payload set 2. The first one is the username payload set, and here we want to load a list that contains the usernames. Now, in a real life scenario, you would use a list much bigger than we use in our examples, because for this attack we're going to use the HTTP default users again, which is in our word list directory inside the Metasploit directory. This list only has like 14 common usernames, but this is just to prove that the attack works. In reality, you would use a much bigger list. Once you select it right here, click on payload set and select payload set number 2. Under the payload set number 2, we want to load HTTP default passwords. In other words, it's called http_default_pass.txt. Double click on that, and it will load 19 common passwords right here. If we just do this and we start the attack, as it says right here, it will have a number of 266 combinations. So this will take a minute or two to finish, but as soon as we start, we notice something strange. Every single request or every single response almost has a different length. So how are we going to determine which username and which password is correct? We need some other approach. So let's close this for just a second. We're going to stop this attack. And let's go back to our page. Once we typed in the incorrect username and password, we got this message right here. So maybe we can use something like this to determine which username is incorrect and which password is incorrect. Let's go back to burp suite. And if we navigate to options tab right here, we're going to see this option that says grep equals match. These settings can be used to flag result items containing specified expressions. So let's clear this list and let's perhaps add this statement right here. So in other words, what this means, let me just paste it first, that it will flag each result that contains this sentence in its response. In other words, it should flag every incorrect username and incorrect password combination that it tries. Let's run the attack again. So go back to payloads and start the attack. Now you can see each of these usernames and passwords combination is getting flagged except one of them. We got this admin and admin combination that didn't get flagged, which means that the sentence of wrong username or password isn't contained in its response. This most likely means that this is a correct username and correct password combination. As we can see, the rest of them are all flagged. And it's still going with this attack, but we can stop it since we already found the correct username and password. In reality, this attack would take much longer with much more combinations of usernames and passwords, and even at the end you might not be able to find any correct combination. Nonetheless, let's give it a try to our correct combination to see whether it worked, and let's type admin and admin. Submit, and it worked. We successfully logged in, as it gave us right here. Now you can try this on other examples as well inside of this Bricks application. However, in the next video we're going to take a look at a more useful tool for brute force attacks, which is called Hydra. Okay, so we've used Intruder from our burp suite to perform brute force attacks. But now it's time to move on to the more advanced tool specifically made for these type of the attacks. And that tool is called Hydra. Now, I said it was an advanced tool, not because the attack itself is hard to perform, but because the syntax for that tool can be a little bit tricky sometimes, and there isn't a unique command that you can run for every website in order to brute force it. So we're going to dissect the command and explain how can you craft one for specific pages. The first page that we are going to take a look at is going to be bweb page on our OWASP virtual machine. So navigate there, and as we can see here we have a login screen. And this is exactly what we need in order to brute force. Now, keep in mind that we do get the correct credentials right here, which is useful for us to practice this attack. So we know that B is username and bug is a password, and this will work once we try to log in. But we want to see how we can get this as an output with the help of a Hydra tool and with the help of usernames list and passwords list. Okay, first of all, to run Hydra, we can open terminal and type in Hydra. This will open its help menu, and this help menu will not be of much use to you once you're opening this tool for the first time. It might seem like it has little options and that it's easy to run, but in reality, once you're brute forcing HTTP pages, there are a few things that you need to take a look at. So let's start off with crafting our command. The first thing that we want to type is Hydra and then the IP address of the target that we are attacking. In my case, it is the OWASP virtual machine, which has an IP address of 192.168.1.11. The second thing that we need to specify is which type of the attack are we performing. So we know that we have GET request and POST request. We can either specify the username and password right here with a GET request or with a POST request. And what will help us determine which one it is if we simply go to View Page Source and we find the form that is used to submit username and password, which is right here, we will notice that the method is POST. So we're submitting the username and password with POST request. Okay, let's go right here and let's type that after our IP address. In Hydra, in order to type that, we type http-form-post. If it was a GET request, you would type http-get-form. Simple as that. So those are the two options that you need to keep an eye on, and usually you will have them inside of the page source of the form that you're trying to brute force. The next thing that we need to specify is the path to the login page. Now, in order to get the correct path, we want to type any username and any password, so I'm just going to type test and test and click on login and see what do we get. So we get invalid credentials, and it's under the path /bweb/login.php. We want to copy this path and we want to specify it in our command. In order to specify it, first thing we need to do is open double quotes. After that, we paste our path and we add 2 dots. Now, why are we adding 2 dots? Well, in Hydra, there are a few things that we need to specify. The thing number 1 is the path, which we specified right here. The thing number 2 is specifying the name of the username field, the name of the password field, and the button itself. Now I know this sounds confusing, but we will do it right now. Hang on for just a second. That's the second thing. The third thing that we usually specify inside of our Hydra command is which error message do we get once we specify incorrect username and password, which in our case is this one right here. And at the end, we add the users list and the passwords list. Okay, so let's go back to the command. We specified at the beginning of the command, and we specified the first thing that comes in double quotes, and that is the path. Now comes the name of the username field, the name of the password field, and the name of the button. So in order to get the name of those fields, we once again want to go to the page source and we want to navigate to the form. Here we want to find the code that identifies the username input, and it's right here. If we take a look at the name tag and ID tag, we will notice that it's called login. So this will be the name of our username field. In order to specify that, we're going to type login equals, and then comes this arrow that is pointing upwards. After this arrow, we want to specify capital user, and then again this arrow that points up. Okay, what did we do right here? Well, the first thing that we did is we specified the name of our username field, and this part right here is just the syntax that tells Hydra to replace this user tag with the usernames that it will read from the usernames list that we will specify at the end of the command. So essentially it will just replace this with all of the usernames that it's trying to brute force with. Same thing goes with password. Now before we specify password, we need to type this sign right here in order to separate these two fields. And now comes the name of the password field, which we can read from the page source, and it's right here. We can see that the name is just password. So let's specify it like that. Password and equals upper arrow, pass, and then upper arrow once again. So the idea is basically the same for the password as well. It will replace the passwords from the list with this pass right here. And we want to separate it once again. And the last thing that we specify is the button itself. So we need to find the button code inside of the page source, and it's right here. As we can see, the name for the button is called form, and the value is equal to submit. So what we want to do is we want to go right here and type form equals submit. That will tell the Hydra tool that once it replaces the username and password, it has to click on a button in order to submit them and check whether they are correct or not. Now that we've finished with the second part of this command, we can go on to the third part by separating it with two dots once again. And we need to type the string that we get once a password is incorrect. And we have it right here. We can copy it, invalid credentials or user not activated. Let's copy that string or that message and we can paste it right here. Once you do that, you want to close the double quotes, and at the end, we specify the usernames list and the passwords list. Now, since we don't have one yet, let's just open another terminal, type ls and nano users.txt. Here we can type any usernames whatsoever. Let's go test123, root, admin, and let's add the correct username just so we can see whether the tool will work and whether it will manage to find this to be the correct username. Let me just double check. Yeah, B is username and bug is password. So we will be adding the correct credentials in the list just for the purposes of this tutorial in order to see whether it will work. In reality, of course you wouldn't know the correct credentials and you would use much bigger lists than this. Okay, let's add, for example, admin123, and that would be about it for our users.txt. Now let's go and do same for the pass.txt, and here will be our passwords. So let's go password, pass123, password123, let's go with bug, which is the correct password, and let's go with test1234. Okay, save this as well. And now we go back to our command where we need to specify that we want to use these two files in order to brute force. To specify the usernames file, we type dash and then capital L. After that comes the name of the file, which in my case is users.txt. And after that we specify capital P for the passwords file. And then the name of the passwords file, which is pass.txt. Okay, this is the entire command, and I know it might sound confusing and you probably have no idea what we did right here, but don't worry, this is the same reaction that everyone has once they first encounter the Hydra tool. And we will be taking a look at another example of crafting the Hydra command for a different web page in the next video. For now, let's go through this command once again and explain what we did. So first we type Hydra, then the IP address of the target, then which type of the brute force we want to perform, based on how the credentials are being processed by the web page. Since they are processed with POST request, we use http-form-post. If they were processed with GET request, we would type http-get-form. After that comes the double quotes part, which has three different things. The first thing, or the first part, is the path to the page that we want to brute force. The second part is the name from the username field, the name from the password field, and the button itself. And the third part is the string or the message that we get once we specify the incorrect username or password. This will help Hydra determine which credentials are correct based on this message. If we specify some credentials and we don't get this message, it will flag those credentials as correct ones and it will output it right here for us. At the end we specify dash capital L and we specify the users.txt file or any list that we want to use for usernames, and dash P and then the passwords file. Okay, let's press enter and see whether this command will work. And you will notice in just 1 second we managed to perform all of the combinations of usernames and passwords. And we got the correct one right here. So not only did this finish much faster than Burp Suite Intruder, but it also outputted our correct credentials in clear text right here. Let's give it a try and let's try to log in, B and bug, and click on login. And here we are. We logged in successfully. Awesome. So once again, this is a little bit complicated, but don't worry, in the next video we're going to check out another example of using Hydra on a web page. Thank you for watching and I will see you in the next lecture. Let's cover a second example of using Hydra on a web page. So in the previous video we noticed that the tool can get a little bit hard with the syntax. We brute forced the DBWAP page, and now we're going to go with the DVWA page. So we're already familiar with this login screen. We know that the username is admin and that the password is admin. But we want to see how we can get that username and password with the help of our Hydra tool. Of course, since this is something that we do for the educational purposes and we want to prove that it works, we will be adding the correct username and password in the users and in the passwords file. So in the users file, from the previous video, we already have the admin username. And in the passwords file, we want to add the admin as a possibility right here. So let's add admin. And now once we craft our Hydra command, we should be able to get the correct credentials outputted for us. Okay, time to craft the command, which is the hard part of this tool. As we remember from the previous video, the first thing that we do is we specify the IP address of the target that we want to scan. Once we do that, we determine whether the credentials are being submitted with POST request or with GET request. To do that, we can go to the page and go on page source. Then, once again, we want to find the form where the usernames and passwords are being submitted. And here we will see that it is once again a POST request. Okay, awesome. So we're using HTTP form-post. After we specify this, we open double quotes. Now comes the hard part. We need to specify first the path to the page that we want to brute force. So let's type in incorrect credentials, click on login, and we get this path. So /dvwa/login.php. Let's copy it and let's paste it right here. This is our first parameter inside the double quotes, the path to the page. Now comes the name of the username field, the name of the password field, and the button name, as well as what to do with the button. So once again, go back to the page source and find the code where the username field is being labeled. Here it is. If we take a look, right here the name of the username field is simply username. So we will type that in. Username equals, then we type upper arrow, user, upper arrow, and then the sign to separate it from the password. Now we want to find the password field. Here it is, right below the username field, and the name for it is password. So let's type that in inside of our command. Type in password equals upper arrow, pass, upper arrow. Okay, awesome. And the last part, which we once again separate with this sign, is the button itself. Let's go all the way down, and here is the button. The name of the button is login, and we submit it right here. So we're going to specify that as login equals submit. And this will once again tell our Hydra command to submit the username and password once it types them in. And at the end, we have a third option for our double quotes parameter, which is going to be the incorrect message that we get for incorrect credentials. Since we typed in test and test as username and password, we got this message down here that says login failed. So let's copy it straight away and let's add it to the end of our command. Paste to clipboard and close the double quotes. This should be enough for Hydra to be able to brute force the page and also determine which credentials are correct and which are not. At the end, all we're left to do is specify capital L for the users list and capital P for the passwords list. And this is our entire command. Let's give it a try. If we run it, give it a couple seconds, and it finishes the brute force once again in around 1 second time. We get the correct credentials right here, which are admin and admin. So we successfully brute force this page, and if we want to, we can log in right here. Awesome. So we covered Hydra tool. Now we are officially done with the brute force part of this course. But in the next video, I also want to show you another possibility with Hydra that you can use besides brute forcing different web pages. It will be a short video and you might find it useful in your penetration tests. Nonetheless, thank you for watching and I will see you in the next lecture. Okay, just a quick video before we finish this section. I want to mention one thing about Hydra. Now, Hydra is a powerful tool. And it's not only useful for brute forcing web pages, it can be used to brute force different services as well, such as SSH, FTP, and others. And in this example, I just want to show you that if we take a look at our OWASP virtual machine and we scan it with Nmap, using -f command, which will scan most known 100 ports, we will get this output. And if we take a closer look at scan results, we do notice that the target has port 22, or in other words, the SSH port open. So we can try to target the SSH port with Hydra brute force attack. So let's give it a try. Now the first thing that you will notice regarding Hydra with SSH is that the syntax is rather easy, or much easier than once you're targeting web pages. All we need to do is specify the IP address, then we type SSH and then -l users and -p pass.txt. And this will run the attack on SSH port with these two lists. Now, since we don't have the correct username and password inside of these lists, it gave us an output that 0 valid passwords found. Now, let's add the correct credentials right here. The correct username is root or we already have root, so we can just leave it like that. But correct password is OWASP BVA. So make sure that you add OWASP BVA inside of the passwords list. And if I run the command again, for some reason we get incorrect or not valid username once again. So perhaps we need to add another option. Let me just go to the help menu real quick. And let's try adding -t option, which default is set to 16. We're going to lower it just for the purposes of this command. So let's type it right here, -t4, and then SSH, and then users and passwords.txt. And here it is. We successfully found the correct login to the SSH port on the target machine. All we had to do is type Hydra, the IP address, -t4, and then we specify which protocol. In our case, we're using SSH, and then the passwords and usernames list. Now, if you wanted to check whether this is correct credentials, you can type SSH 192.168.1.11. Here you want to select yes, and pardon me, we need to close this because we're trying to connect to the Mr. Hacker account on the target machine, which is non-existent. So we must type SSH root and then add this IP address right here. Then we press enter. It will ask for the password, and here we type OWASP BVA as the password for the root account. Now we're logged in on the target machine over SSH, and we can execute any commands that we want on the target machine, such as ifconfig, such as whoami. We can type ls, we can change directories and see all the files on the target system, just because we successfully brute forced the SSH. From here, we can delete the entire website if we wanted to. We can delete the operating system, we can create files, delete files, and do pretty much anything that we want. Okay, I just wanted to show you this, that there is another possibility with Hydra besides just targeting web pages. Nonetheless, we're officially done with the brute force section, and in the next lecture, we're going to take a look at sensitive data exposure.